Hi, thanks for joining me at NTMEA Virtual Tech Event. My name is Hardhat. I'm an engineer at CNIS APIs team. Blockchain is a buzzword in the industry at the moment. And when I have this conversation with other engineers, I hear different opinion about blockchain. Most of them are right. Sometimes they ask, how do I get started on a blockchain development? So today I'm going to show you how you can start on your blockchain development using Ethereum. Before we get started, let me explain some of the basics of blockchain. There is no single word to explain what blockchain is. Blockchain is like a linked list or a chain of unique blocks, and all these blocks contains an immutable record of transactions. All are encrypted, and each block connected to the previous block, so that you can trace back from the last block to the first block. The main feature of blockchain is the decentralization. There is no central authority who is handling the creation of the block and maintaining the block. The blockchain data is distributed across different nodes, and each of these nodes can either contain a full copy of the blockchain or a partial copy of the blockchain. Every node is self-sufficient. They're independent of each other, and there is no central authority who maintains the network. Some of these nodes participate in the block creation that is known as mining. So if you might have familiar with the word Bitcoin mining or Ethereum mining, that's actually the block creation. Without a central authority, there is some way the system nodes has to agree to maintain the state of the system. That is known as consensus protocol. It's just a simply it's just a system agreement across the blockchain network, and is defined by the protocol. There are mainly three type of consensus protocol. The main one is proof of work. The first blockchain network, Bitcoin network, supports proof of work. The second one, Ethereum, which support proof of work at the moment, and will be upgraded to the proof of stake in the near future. And the third one is proof of authority. Let me explain a bit more about all this. In a proof of work model, the node will participate on the block creation, will create a hash of the transactions. It will do some mathematical logic to create a hash, which is determined, and the complexity of the hash is defined by the difficulty maintained across the blockchain network. Once that block is added, it will propagate that block to the entire other nodes in the network. And if somebody, all other nodes are agreeing, or at least 50% of the nodes are agreeing to that block creation, then it will be added to the blockchain network permanently. And the miner will be rewarded with the native coins. So if you remember the mining, in a Bitcoin network, the mining will be rewarded with a native currency called Bitcoin. In a proof of stake model, each node can participate in the block creation by staking the native coins held by the node. Most of the new network comes in. Ethereum will be upgrading to the layer 2 solution. You might have heard about Ethereum scalability issues and the layer 2 solutions. All those new blockchain network coming in will be following the proof of stake model. Finally, the proof of authority protocol. This is mostly used in private and consortium blockchain network. For example, if banks wants to create a blockchain network between other banks, they will go for a private blockchain solution rather than putting something in an Ethereum Ethereum or a Bitcoin where it's actually a public network. Any node can take a copy of the blockchain network. Proof of authority will be used for in those kind of public or consortium blockchain network. Most of the times, the block creation will be happening in a round robin fashion. Each member of the consortium will take a turn to add new block to the network. When you are into blockchain network, you might heard the word Web3 a lot. Let me explain what it is. When we initially had the Web 1, this was only static files. I never used it, so I didn't really know that. So it's like a static file. You can go for a URL, get a static content from it, and run it in an HTML page. The second Web 2 model, where you can actually create the content and read the content on a website. This is what pretty much all the sites or all the apps we use at the moment. On a Web3 model, it's exactly the same copy of Web2. Instead of having that central authority who maintains the data, data will be maintained across blockchain network, and it will be distributed. Every blockchain network will have its own nodes, and it will be decentralized. So there is no central authority there. You might hear the word coins or tokens in any kind of blockchain discussions. Let me explain what the difference between these two. Coins is actually a cryptocurrency that runs on a blockchain. For example, the first cryptocurrency is Bitcoin. It runs on the Bitcoin blockchain network. And it's also sometimes referred to as native tokens. And the miner who is participating in the block creation will be rewarded with that native currency. And the transaction fees and everything on the blockchain network will be paid in that native currency. On the other hand, a token is a digital asset created on the blockchain using a smart contract. The famous example is SHIB token. So it's an ERC20 token deployed on the Ethereum network. So it's a smart contract. So I'll explain how the smart contract later down in the session. Tokens will be mostly created using a smart contract. And there will be so many other smart contracts on the blockchain network. So all these are called tokens collectively. Today we're going to use Ethereum for our development. We will develop a smart contract in Ethereum. As you know, Ethereum is the first blockchain network which started supporting a smart contract. You can write a code and deploy it in the block. The Ethereum virtual machines can run that code and give you the response back. And it uses Solidity as the programming language. That is enough for the basics. Let's see what we are going to build today. For today's demo, we're going to build an NFT market for selling a Tesla. So it's going to look like this. And we have three different screens for this UI application. One is an Explorer collection where all the digital Tesla collectibles will be displayed. And there is a My Collection tab, which will display the digital Tesla collectible of a particular user. And finally, there will be a screen to sell your Tesla as a digital collectible to the NFT marketplace. We'll start by setting up the UI application. Then I will explain what are the libraries we will be using. We'll start writing the smart contract. We will need two smart contracts. One is for the marketplace and one is for creating the NFT, which is ERC721. Then finally, I'll show you how you can set up a Metamask wallet on your browser and get that smart contract deployed to a public test network. Finally, if the time permits, I can show you how we can connect the UI application to that smart contract. Let's get started. For building the UI, we're going to use Next.js, which is a React framework. And for the CSS, we're going to use Tailwind CSS, which is actually a JavaScript library for writing CSS. And we're going to use Hardhat. Hardhat is actually a development suite for compile, deploy, and test your Ethereum code using in Solidity. And then you can actually test it, and you can even connect to that local network using Metamask wallet. And then do the testing before you publish to a test network or a proper public network. And we can use OpenZeppelin. OpenZeppelin is, you could say, as a library. So we have a lot of Ethereum improvement protocols defined. So OpenZeppelin has developed most of this EIPs into a library. So most of the famous ones are ERC20 and ERC721. We are going to use ERC721, which is an NFT standard for building our NFT marketplace. So they haven't written most of their Solidity code so that we can reuse that. So we're going to use an OpenZeppelin to inherit some of those things. I'm going to walk you through how do we inherit and all those things when we are actually doing the coding. So we are also going to use an IPFS. IPFS is a decentralized file storage system. We're going to, when we are deploying an item to the marketplace, and when you're creating an NFT item, you probably need to keep some meta information about that item. So you can give in an ERC721, you normally give a URL to the market item. You can even write Solidity code to store this information, the metadata about the item into the Solidity itself. That's going to cost you a lot of money because that involves a lot of transactions to save that information, and then it's being its own blockchain reading could be a bit difficult. So we're going to save that information in a file to an IPFS, which is again another decentralized file storage system, and then we're going to send that URL into the blockchain node. And we're going to we will use Axios, which is a network library similar to Fetch. The next thing we're going to use is the Web3 model. When you are creating a transaction on an Ethereum blockchain, you need a signer. So we're going to use Metamask wallet as a signer. So Web3 model will initiate whenever we need to use an information. Web3 model initiate that, bring up the Metamask connection. So if you think of like a Google login with Google, or log in with Gmail, or log in with Facebook. So it's going to connect to the Metamask wallet and ask for the information, and then it'll give you the amount of ethers you need to process the transaction, and things like that. Okay, let's just coding. So first we're going to create a Next.js app. So create Next app, then we call it marketplace. Then let that finish. And so the next thing we are going to look at is actually installing the Tailwind CSS. We're going to copy this and execute this command. So we're going to install the let's go in the marketplace. Then let's install some of the dependencies for the Tailwind while it's happening. So the next thing we want to do is initiate the Tailwind. So npx Tailwind CSS init -p, that's going to initiate the Tailwind. So that'll have a few things here. So that's going to initiate two files, Tailwind config and post CSS config. Let's go move ahead, and then we will install the Hardhat, so which is the Ethereum development suite. So we can install Hardhat. Along with the Hardhat, we need to install a few more dependencies so that we can deploy and develop the code on a local network. So we're going to install, copy this, and deploy all this commands. So let's just finish. Seems like it's taking some time. So let me install the other dependencies. We go back and then copy the meanwhile we can copy the OpenZeppelin npm installation. So we're going to install the OpenZeppelin. Let's install the IPFS. And we will install the Axios as well. So let's install the Axios, and finally let's install the Web3 model. So npm I Web3 model. Okay, so those were the dependencies we need. Let's open up in a code editor and see what we actually did so far. So like we initiated the Next.js. So if we go to the Next.js documentation, you can see how Next.js works. So it's like a React framework. You don't need to install the navigation libraries and things like that. It's all pre-built in, and for the server-side rendering, it's pretty handy. And so you read through the documentation of Next.js. So it's something worth to check out. For configuring the Tailwind for particularly for this for Next.js for our project, we're going to change something with the Next.js, and there is a file called global CSS. That's what we're going to change that. So we're going to import the Tailwind base and few other components directly from Tailwind, just so then everything will be covered. So let's go and look at the initial screen, which is this. So we're going to delete some of the stuff. We don't need this. So let me then go to the network and just say yarn dev. So it should start the screen on locally on our localhost 3000. So that's our UI. There is nothing much. So I deleted most of the files. So that's the UI. So let's go back. Next thing we want to do is actually initiating the Hardhat project in our code base. So we gonna copy this npx Hardhat and then put npx Hardhat there. That will initiate our blockchain code. So I'm gonna create a sample project. I'm gonna leave it in the marketplace folder. So that's gonna then there is an ignore, and then you have to, yes, you can send the data, then that's it. So let's go back and see what it's actually created. So if you look at the code base, there is a contract folder which is actually created by the Hardhat. Then there is a sample Solidity code, and there is a bit more, few more files which are the Hardhat config. This I'm going to walk you through how some of these things, how it actually works, and what you need to configure when you are actually developing few of the things. I'm just going to delete this, probably not required, so we're going to leave it there for now. So we'll come back to this. We need to configure the local network and things like that. I'll come back to this in a minute. And also there is a sample test file. You can see that. So this will actually run, it is more like a TDD. So it's gonna create the contract and deploy it, and then it make sure that it's all working fine. So let me just go ahead and test this on how whatever the samples file created. So I'm gonna type it npx hardhat test, and it's gonna deploy that created contract. So it basically did that, and then it's saying that it actually got a greet back from the contract. So let me go back to the contract file and see what actually defines. When we are creating a Solidity file, the first thing you want to define is the license identifier. So that's the standard. It's saying that what license this file has. So that's the first line. Then the Pragma Solidity is actually the compiler version. So there are so many Solidity language versions. So and it's keep on changing. So if you want to use some of the latest features, you have to mention the compiler, which kind of Solidity code you're actually using for that. We probably have to define that in the Hardhat config as well. So if you look at that, 084 is already defined the Hardhat. So we're going to make sure that something similar is defined in your Solidity file as well. Let's just start writing our marketplace contract. So let me go ahead and delete some of this stuff. So I'm going to rename that to marketplace test.js. Then I might have this. So I'm going to change this to marketplace. And so we're going to follow a TDD development. So we're going to write the test, and then first thing, let me change this. So first thing we need is actually, we need two contracts for our marketplace. One is a marketplace contract, where is consider it's like an Amazon and a product in Amazon. So we need something for the Amazon, which is the marketplace, and then we need something for the product, which is an NFT. So we need two contracts for that. So the first one is called the marketplace. So we're going to get the marketplace contract, and we're going to make sure that that is getting deployed. So that's going to be the marketplace.deploy. So that will be marketplace. Then we're going to make sure that the marketplace will be get deployed. Then we're going to delete that. And the next thing is we need the NFT. So we need the NFT contract. So first thing is NFT. So we're going to say that Ethers.get factory contract, and something called NFT. We're going to make sure that the NFT contract is read. Then the next thing is NFT deploy. Then we will make sure that the NFT is got deployed. Then the thing is await for NFT to deploy. So once that is done, so our contracts are getting deployed. Now if I run the Hardhat test, it's gonna complain that there is no contract. So because we haven't wrote the contract yet, so we need to first write the contract and then come back here and run the test again. Also, I'm just gonna rename that to marketplace. Then I'm gonna delete everything here. So this is actually the marketplace. We're gonna import few things from OpenZeppelin. I'm gonna show you that in a minute. So but before doing that, I'm just gonna import what is there here. So this is our marketplace contract. So let me go and run the npx hardhat test again. So this is again saying that the NFT marketplace, we haven't got the NFT contracted. So let me create so if we do this, let's see what happens. Saying that the contract has actually got deployed, even though it doesn't have anything. So it's just gonna deploy that contract. So you won't be able to, because we haven't wrote anything in the Solidity code, so we will not be able to interact with the contract, but this will still gonna get deployed. So that's the basic contract you need to deploy to any blockchain network. First, we're going to write the NFT the NFT item contract. So we're going to import few things from OpenZeppelin. So we're going to start with OpenZeppelin So we're going to enter the counters because we need an item. So I'll explain all those things later. If you go to the GitHub documentation, you would be able to see for creating an NFT, what kind of things you need to import it from. So we're going to say this is ERC-71 UI storage. So that's going to give you, what does this mean is we are creating a contract called NFT, and we are going to extending it from existing another contract called ERC-720, which is like a library or a class. You can see that. So that's what we did on the first line. So every item we create in a marketplace, we need to have an item ID for that. So when normally in a DP, you actually use it as a primary key, right? So when in a Solidity contract, you define a private variable that which you can save it in the block. So for that example, we're going to use something called counters. So we say using counters for counters.counters. It's just a way of saying that, okay, we're going to use counters.counter for creating an item ID. So what happened is that counters.counter, then we need to create a private variable called token IDs. So that's that element, a private key for that particular token. Seems like there is, so it should be actually counter.counter. So we're gonna see that. So that's gonna be counters.counter. Then it's the same thing. It's just like a defining for anything defined as counter.counter. We're gonna extend it from this counters.sort. So that's the first thing we did. The next thing is we need an address to the NFT marketplace. So we say NFT marketplace address. So it's just a variable we're gonna store it, and we need the reason because when we create an NFT, that NFT belongs to the owner, but we want the NFT marketplace to make any transaction on it. It's like an intermediary, right? So marketplace is an intermediary. So marketplace will need some kind of capability to transfer that NFT from you as an owner to some other person. So that's what, like when people are actually buying it, so we need to transfer that. So that's what for that we need the NFT marketplace address. So we won't be able to deploy this contract until we deploy the marketplace contract. That's why I'll come back to that in a minute. So let's write the constructor. So we're gonna pass some things to the constructor. So constructor should get the address of the NFT marketplace. Then we need to call it as a public function. We don't need this, but we're gonna set that NFT marketplace address to the NFT marketplace. So that's actually the variable we gonna save it against. Another thing is actually we need to call the ERC-721, which is actually the NFT contract written by OpenZeppelin. We need to pass few things. One is the name of the NFT item. Then the next thing is actually the code. So if you go to OpenZeppelin, you would be able to see what exactly I meant by that. So we need to, when you actually create an NFT marketplace, so NFT, so when you are extending it from ERC-721, so you need to pass the an element name and then the contract name and then the short code for that contract. So we're going to do the same thing here. So this is Tesla NFT marketplace, and then we pass it called TF NFT. So we're gonna, these are the two things we need to deploy the NFT marketplace. So yeah, so we create the constructor. Okay, so I'm just going to leave it here for now. Then we'll come back to this. We need to create an item. We need to mint an item. So those kind of codes we still have to write. So before we do that, so I'm just going to leave it here and start writing the marketplace contract. For the marketplace contract, we need to import few things. So first thing is, again, for the marketplace, we need to maintain some kind of count. For example, like the item sold. And we're going to save that in the block, and against an address, we can actually say that these many items are sold. Then we would be able to do it on the fly. But that's still, when reading from a distributed blockchain network, it's not very efficient. So that's why we're going to keep something called items sold and items listed in this any number of counters we need for the marketplace. So we're going to keep that. So that's why we need the counters. The next thing we are going to import is actually called entrency card, which basically we are talking from this contract to another contract. So it's like a protecting layer which can avoid any kind of duplication of calls and things like that. So any kind of intervention from someone else when we are making call from one contract to another. So it's always better to use the reentrancy guard. And the next thing is ERC21. So let me just extend this. So we're gonna extend it from reentrancy guard. That's the first thing. For then the same thing we're gonna do is using counters. Then we for the counters.counter we need two things. One is items listed. So that's the first thing. Then we need something for items sold. So this is the two list items we need. The second thing is when you deploy the smart marketplace contract, so that will be assigned against an owner. So you are actually the owner of that marketplace. So we need something for that. So we need called private owner. So that's a marketplace owner. So what happens is that we need a constructor. So we got a constructor, and then we need to change the owner to something called message.sender, and this should be a payable one because we gonna change every time when there is a transaction happen. So we need to deploy one more thing. So we need something called listing price. So as a marketplace owner, you need to get a cut of what the NFT is getting sold on your marketplace. So you need to get a listing price for that. So for that, we're gonna say something called listing price. So we want to make this public so that anybody can actually read this. So we'll just list it as a public listing price. So that's what the contract. We're gonna add few more things into it. Let's go back and see what happens without testing. So if we go back and run out npx hardhat test again, so this actually gives you an error saying that there is a missing argument for the constructor. We have an NFT marketplace. We got deployed the NFT marketplace, and then for the NFTs, we need to pass the marketplace address. So we define in the constructor a variable saying that NFT marketplace address. So we need to pass that thing. So let me go back and change the testing code and pass the NFT marketplace address to the NFT. So if I change the testing code, so we have the marketplace here. Once the marketplace is deployed, then we would be able to get the marketplace address from it. So we have this marketplace.address, and we're going to pass this to the NFT NFT contract. Let's run the test again and see what actually happens. So we have the marketplace which is deployed, and both contracts are deployed. Let me go ahead and make some changes to this to the testing. So we can write so we're gonna what we did is we actually write a before each, which we will deploy the contract, and then we can actually do everything after that. So we're gonna get the market address and contract address to a variable. So what happens is that every test runs, this will get deployed so that you will get a new instance of the NFT marketplace. Then you can write individual test on top of it. So this is what I did. Now that we created a before each function, so the next function we're gonna write is actually a test to get the listing price from our contract. So let me just say this. So we're going to write a test, which is for getting the listing price from the contract. So we're going to call a function called get listing price, and then we're going to make sure that that listing price is actually matches with whatever you have set up. And if you run this right now, because since we don't have that get listing price there, it should actually fail. So this is saying that there is no get listing function. So we're going to go to the marketplace contract, and then we're going to write a function. So for the function is actually get listing price. So get listing price, we don't need any parameters, and this should be a public function, and then it should be, because it's reading something from the block, so we need to put the view there, and then it's going to return at 256 cent, and then it's going to finally return the listing price. So we wrote this function. Let's save this and run the test again. So this time this test should pass. That when we actually integrating with the UI, we'll explain why we need to do this, get this listing price before before creating a new NFT item. The next thing we want to do is we want to list an NFT item to the NFT marketplace. So let's write some code for that. First, let's write a test which we could create an NFT listing, then make sure that that NFT listing is actually created in the marketplace. Let's do a test for that. So this is what the test for this. So what we did is we created an NFT token. So we gave him a sample URL, it's a token URL. Then once that is done, we wanted to get the listing price. The reason for we are getting this listing price, meaning when we create the marketplace, there was a listing price created by the owner, so that somebody who can actually take the commission from any price sales, any item sales in the marketplace. So we need to get the listing price first, so that that's something set up in the marketplace contract itself. So we want to get that. Then next thing is actually we wanted to list a auction price, right? So for every item we are going to list in the marketplace, you need to have an auction price for it. So we're going to set an ether here. So ethers have some kind of a utility where you can actually pass the unit to whatever you want, gateway or ether. You can still do that. So I'm just create something into one ether. The next thing is we create from the marketplace address. We're going to create a call a function called list. Then we pass the NFT address, which is the NFT address we created, and then we pass the NFT ID, the token IDs. We get for the time being we just put 1 and 2, and the auction price. And this part is something which comes from when we have the signers or a wallet connected. This value will come from the wallet, so that meaning when somebody is trying to create a listing, they need to have some kind of an ether balance on their wallet. Then only they would be able to process the transaction. That's why we are passing it as a value. Let me just run this and see what's going to happen, because at the moment we don't have a listing list function in the contract. So let's go back and write this list function. So we are at our marketplace contract. Let's write a list function. Before we do that, there are a couple of things we need to change here. So every item, if you remember, when we create the NFT contract, we have something called item token ID, right? So that's actually a key we store it within the block, so that we can refer whenever there is an item, we can refer it back for our front-end usage. Similarly, we need to have a list of item IDs listed in the marketplace. So we create something for that. Then some couple of other counters for us to use our front-end solution. So when we are listed, so I'll explain that when we actually create that function. So in Solidity, when you wanted to create a custom data structure, so custom type, you can use something called struct. So we're going to create, at the moment we for all our marketplace items need to have a separate it will be a separate type. So we need to first we're going to create a struct type for that. So this is what the code look like. So we have a market item, so the item will have an ID, that's the item ID. Then the NFT contract address, so that's where this NFT is actually deployed, and then the token ID of that NFT from the NFT contract. Then the next thing is the listed by, who is actually listed this item. Then the other item is owned by, who actually bought this. So the other thing is that price and boolean. So sold boolean, because the reason we are keeping a boolean, because we wanted to, in a front-end application, what we wanted to do is we wanted to fetch all the listings which are not sold yet, and also fetch all the listings which are sold. So that's why we are actually keeping a loop there. So we created a different type, new type. Then the next thing is we wanted to create a mapping to our that custom type. The reason we are doing that, if you think of like a hash or a map where that item ID is will give you the item details back. So that's what we are doing here. So in Solidity there is something called mapping. It's like a key value pair. So key is the item ID, and then value is actually the opposite of that market item. So we're gonna take that into something a new variable called ID to market item ID. The next is we need to have the function to list the market. So list items. Let's write that function. So for listing that item, if you go back and look at our test cases, we are actually passing the NFT address, token ID, auction price. So we need 3 parameters for that function. So first thing is the NFT contract, then it's the token ID. The third thing is actually the price. There are a couple of things we wanted to notice here is that this is a public function, which means we can call it from outside, and it should be a payable function, meaning you're going to make a transaction here. So what is that transaction means? You are actually transferring it from the send whoever is created to this address. Once you list an item in an NFT token, that item will own by the owner who are actually creating that item. So when you actually list an item in the marketplace, you are giving the marketplace the full authority to sell that item on behalf of you. So that's what we did. So that's why it has to be a payable address. So that because it makes some transactions there. Okay, so what we did is there are a couple of checks we need to do. So it's like an if-else condition in normal programming. So you can use something called require. Then we want to make sure that the pricing should be always more than 0. So we actually create this and saying that, okay, the price must be at least 1 ETH. And so that's what we are actually doing here. Then the second thing is message.value. This comes in when you message is actually a metadata comes when you're actually making a transaction to the blockchain. So it comes from a wallet. So all this is part of the Solidity block creation. So the blockchain, you have that message metadata which can give you the address, who is actually initiating, and value and things like that. So we're going to get the value from there. So if you go back to our test cases, I defined the value as a separate object. So that's what this last object message, it comes as part of the message metadata. So we're going to make sure that the listing price must be equal to the listing price of the marketplace. So that's what we defined earlier previously here. So 0.25 either. So you want to make sure that that listing item is matching that. So these are the two if conditions. Make sure that this is passed before we doing anything else. The next thing is, like I mentioned earlier, every items we will keep a counter in the marketplace to see how many items are listed and a private key for that item. So we increase the item ID, that's the item ID, we increment that. Then we're gonna create that item ID with the current, you will read the current value, and we're gonna put that into the key value pair. So if you remember the key value pair here on top, I'm gonna pass the item ID and put as a new object called market item into that. So one thing we did is, so we need to, when you're actually defining an address in Solidity, you can define as a simple address or a payable address, because this involves a transaction. At the end of the day, when somebody buying an item from you, you have to make the transaction to the owner, and at the same time you have to make a transaction to the whoever is buying, the buyer as well. So that's why we are creating this addresses as payable, and we are putting the price there, and also putting the sold value, sold boolean as false. Then what we do is we increase the number of items listed. So if you remember how many items, we are actually keeping a counter for getting the number of items listed in the marketplace. So we can do that as well. So increase that. The last thing what we did is, if you remember, we are actually extending something called ERC721. We are gonna pass that IIRC events and events, which is part of the OpenZeppelin contract, to move that NFT contract from the owner to the marketplace. That's what we did here. We're going to pass the token ID, then we're going to pass this address, so which is address, this means the marketplace address, and then the message search sender, because you listed the item. So now you're actually authorizing the marketplace to do the transaction on your behalf. So that's what we did in this code. Okay, let's go back to our function. Let's save this. Let's go back to our function and start running, do the test. It should actually work now. Okay, so that actually passed. So it listed an NFT token. What we're going to do next is create a market sale. For that, we're going to write a test for that. Okay, we wrote a test. So what happened here is we created a token, we got the listing price, everything like we did before, and from the ether.signers, when you actually Ether provides a lot of utilities, Hardhat provider, a lot of utilities give you the accounts, probably somewhere around 10 accounts to do with their local blockchain. So we can actually get that addresses using this function. So you get signers will give you the address. So the first one we anyway used for creating the market, listing the NFT token and creating the market and all those things. So here, what we're gonna do is we're gonna get a second address and make a transaction on based on make a purchase on based on for that second address. So we have to write a function called create market sale, and for that address, what we're going to pass is an NFT address, because that's what eventually we need from the marketplace, right? So give the NFT address, and then the marketplace will make sure that you are actually paying everything, and then it'll transact that NFT to your name. So and value is actually the auction price. So what happens here is, when you eventually doing it from the UI, the auction price will come when you are connecting to the Metamask wallet, and you need to have some kind of auction price need to be in should be in your account to do this transaction. So that's what we did. Okay, let's run this test and see what happens. So as usual, this is going to fail because we don't have that create market sale function there. Okay, let's go and write that create market sale function. Let's write a create sale function. So first thing we need to do is define a function named create function name. So we can create market sale, that's the function name, and we need an NFT address and an item ID. And next thing is, again, it's a public function, and we are going to make some transactions. So it's going to be a payable function, and then we have the no reentrant modifier there. Within that address, we need to get when we get an item ID. So we're going to get past the item ID from the test case. We're going to get the item ID, and we go to our map key value in the blockchain, which is the item to market ID, get the price of that item. Then next thing is actually get the token ID, right? So this token ID is what we used in the NFT contract. So we're going to get the token ID. Then we want to make sure that the message.value, whatever we passed as a value from our wallet, so we want to make sure that that is actually matching with our price in order to complete with the transaction. This is an if else case, otherwise the transaction will fail. The next thing is, we wanted to make sure that the ID to market item listed by is transferred to this whatever that message value, the item listed for a price, so that price should be passed to the seller or whoever is actually listed this item. And then we need to change the contract from a marketplace. We need to change the NFT contract, transfer that address from NFT marketplace to the owner, whoever is actually buying this item. And after that, once that is done, then we are going to change our ID to market system key value pair with owned by to this whoever is bought this item. So we're going to change that. And once that, we are going to change the boolean to true. So after that is done, so we keeping a contract called item sold. So we're going to change that. We're going to increment that to 1 so that we know how many items we sold in the marketplace. Once that is done, so the next step is actually paying the owner. So we wanted to pay the owner a listing price. Whoever is actually created the marketplace will get a commission, like we discussed before. So we want to make that transaction the listing price as well as this. So we're going to pass that. Okay. Okay. So that is done. So let's go back and run the function, run the test and see whether it works. Okay, so that actually created a market sale. So we have most of the functionalities here. So we have the functionality to create an NFT. We have the functionality to create list an item in the NFT marketplace. We have the functionality to make a sale in the marketplace. The rest of the functions we're gonna come back and write it when we actually building the UI. So it makes more sense when we do that along with the UI. With the magic of pre-recording, I managed to complete some of the things for our UI. So let me show you what I did so far. So this is what our Tesla NFT marketplace would look like. So we have a page to explore the collections. Then we have a page to show my own collections. And finally, we have a page to list your Tesla for sale. So this is the simple UI where you can list your NFT and go and explore the NFT from the marketplace, and then you can go and explore your collections. And there are a bit more options here, like buy now, which is what we that's where we make a sale on the NFT marketplace. Let's have a look at the code base so that it makes sense. Next.js, as I mentioned, is a framework for React. If you're building an application using Next.js, you don't need to include any of the routing libraries or any those sort of libraries you need normally use it with a plain React application. So if you want to create a new page, so you have to create that within the pages folder. And then there is something called underscore app. This is the common file which will be rendered based on whatever the configurations. It's when you configure the project for the first time, this will have a component in place. So I added a few more files here just to render the navigation and also the logo on top of the screen, like like you're seeing here. So once that is done, so the first page is always as the slash router is actually the index page. So for the index page, what I did is I just simply initiated a state using useState. I listed a few listings for the NFTs, and then I'm looping through that to list that into a screen. So I created the component to do that. So that's what it's all about. And for the Tesla, my Tesla page, which is the collection page, will have the similar thing. So instead of showing all the collections in the NFT marketplace, you're gonna show only the collections which belongs to you. So if you remember, we haven't finished the function to read these NFTs from the marketplace in our contract. So that is not completed yet. So the reason I wanted to do show the UI, then put that thinking perspective so that we can come back and do the coding for the pulling all this information from the marketplace. So all this information is static at the moment. So we will connect to the actual marketplace once that API is ready. So that's where we connect an UI application like React to a blockchain system. So something to think about. And finally, the last page is for selling the listing your NFT Tesla for collection. So for the sale. So I created a form input. So as you can see that you have form input here, which basically are asking you for name, description, and price, which is in Ethereum, and then the file to choose from, and then finally a button to click that to list it to the marketplace. This is where if you remember the function for create a list an item, will get called listed to the marketplace as well. So two calls are happening here. Okay, let's go back to our marketplace test code and start writing a test for pulling all the items from the marketplace. So that should be an async function because we are connecting to the blockchain and we have to wait for that to come back. So that's going to be an async function, and then it's going to be marketplace dot fetch all items. We can actually use something like the item count here. So items here, that's all the items. Then at the moment this should be 0 because we don't have any items listed. Items dot length, then we can say that okay, this is all working fine. Let's go back. Let's run the test again. So npx hardhat test, saying that we don't have that marketplace item. So we need to go forward and write that marketplace fetch all items function in the marketplace Solidity code. So let's start writing the fetch all function. So the function is fetch all items. Then it should be a public. We are not going to get any arguments, so the public function should be there. Then the market item is the type we're going to return it back to the function. So that means it's going to return a market item array. The next thing we wanted to see is for fetching all this information, we need to create an array. We need to create a marketplace items array and then send that array back. To do that, we first need to know how many elements are there in the marketplace item itself. So we need to initiate that array with the size, specified size. To initiate that array, so we need to initially figure out how many elements are needs to be, what should be the size of that array. So for that, item ID count, we can get the items count from number of items listed dot count. So if you remember, we have a counter which have item IDs, so we're gonna get that counter from there, and that's one thing. So then the next thing is we wanted to get the number of sold items, right? So item sold count, so we have something called items. So we need to go back and see, get the number of items sold to current. So if we get these values, you know the difference between. So if you go and get the difference unsold count, so we can get the item count minus item sold count, then we will get the unsold item count. So that's what we need to use for initializing the array. So let's initialize the array. So there's going to be a market item, then it'll be on the memory, then the number of items, then the item unsold item count. So that's the first thing, we initialize that array. The next thing is we need to write a for loop for running with the array, because we have a mapping, so we have the item count. This should be the number of unsold item count, right? So that's gonna be the unsold item count. We wanted to no, this should be the item count, because we need to loop through. There is no way to simply fetch it like a DB. There is no way we can simply pull the information from there. We have to loop through everything stored in the marketplace and figure out whether the item is sold or not, and then include it in there. Before we do that, we need to initiate something, a counter for the array, current index for our array, because if you think about it, the loop, we can't loop the loop element I. So we need to initialize another variable for sending into our, to keep a loop for our array index, right? So we got that. So what we're doing here, we are looping through everything in the id to market item, and with the item count as the index. Then we're checking that whether it's sold or not, that if that flag is enabled, true or false, depends on that, we're gonna decide whether it's a sold item or not, right? So that way we are adding to the items array. So there is a current index we need to add. When we actually do that, we need to increase that current index, because every time you add an item to the array, you need to increase the index as well. So that's what we did there. And once that is done, then we have the items here, then this should return the items. Okay, now if we go back to our terminal and run the npx hardhat test again, because what we expect is we don't have any items listed in the marketplace yet, so we gonna get an item length should be 0. So that's what we did here. This is all passing. So that's the first test is passing. Now that we have the fetch all item in the function there, so we can add some more information, some more tests to make sure that this is all working fine. Because previously, if you see that we already created a list item function to list an item in the market for sale, so we can use the same function. So list an item and verify the item exists. So that is the next function we're going to write. So we're going to list an item like we did here. So before we do that, so let's say make sure that the initial items list are 0, and then we're going to list an item here, list an item, and then once that is done, then we wanted to make sure that the items list items after listing is, we're going to fetch that again. Then after list for length should be a 1. So let's go there and make sure that our tests are actually fine, so that we initially, if you think about it, we didn't have any items in the marketplace. We were not even sure whether it's the items are returning back to our code, right? So let's just make sure that it's all working fine. Okay, so that means it's coming back. So that will cover us for our explore collection screen. So if we make it that fetch all my NFTs, fetch all my collection items, should can be used for this particular screen. Now, if you think about it, so the next screen we wanted to is fetching my collection. So if we can use the same function. So we're gonna write another function. Uh, so this should fetch my items. So as a user, when I'm going to the second tab of my UI, I should be able to fetch my items from here, right? So we're gonna do this, fetch my items. Then we want to make sure that at the moment this is not listed. I mean, there is nothing listed. So let's run this test. So this test will fail because we don't have the fetch my items function in our marketplace. One thing we didn't do with this that when you're fetching the items for a particular user, we should initiate that user ID and probably like a user address there. So for doing that, if you remember, when we had this previous test where we are making a market sale, we fetch the address from the signers. So here we're going to do the same thing. We're going to, because we're going to use the second address. And then the second next thing is we wanted to connect to the marketplace with that second address. Then do the fetch my items. In this way, when we write the function, we can do the message.sender. So that message.sender address will be the address of the user. So we can make sure that we are fetching NFTs belongs to that user. So let's go back to our function and then start writing our fetch my item functions. So first function is fetch my item, right? The name is fetch my items, and it will be something similar to the last one because we have to view and returns the marketplace item, which is memory. Then from there we have to return the array of items. So for doing that, we need to first get the item count. So that's the number of items in the marketplace. Next, we need to figure out how many items are there for this user. So let's initialize something for that, right? So let's put a 256 users item count, which is 0. There is no easy way to figure this out without looping through the entire marketplace items and figure out which one is owned by the user. So that's what we are doing in the next step. So what we did is we are looping through the item count, and then for each item we are passing that take the on by, which is that is the user who's actually owning it. Then we're taking that whether it's a message payable message.sender. Then we are increasing the user item count. In this way, when we are initializing the array of market item array, we know what is the count for that particular user. Let's copy the function from the previous one. Let's go there and we can modify that later. So what happens here is we initialize the items and we need to use the user item count so that we initialize the return array of items. Then we're going to keep a current index. Just for that we can increase it, the array index, when we are adding something to the items array. And we will loop through it, and we're gonna have to check this on by is equal to payable by address. So that is again something we need to do here. Let's just save this and say return items. Now we'll go back to our test and then run the npx hardhat again. So we were checking that the item dot length should be 0 because this user don't own anything in the marketplace. This is just a first one test which is verifying that the user don't have anything, right? Let's list something to create an item in the marketplace. Make sure that item is there. Then we will make a sale to this address. Then we will fetch the listum for that. Then we will again fetch all the listum unsold items from the marketplace. Make sure that it reduced by 1. So it's a big test. So we want to make sure that everything is fine. So let's start writing that test. The test should say that, okay, it should create an item, make a sale, fetch users item. So for doing all this, we need to first create item in the marketplace. So for that, initially we will go and fetch all the items in the marketplace and say make sure that there is 0. And next thing, we list something in the market. So we're going to copy the same function from our previous test. Now if you remember, we did some market sale previously, right? So we will take the address from here, the second address, and we will make a market sale with the auction price. Then we will fetch that for item for that particular user. This should be 1. It's a very lengthy test. Let's see, and let's run this and see what happens. I made some mistakes here, so I already have the items. Items before listing, so that should be there, and then item after listing, that is fine. Then items after sale, or items users items, so that is fine. So let's run this test and make sure that something we wanted to see whether it's actually test is working fine, right? So we will add a console.log. There is something is wrong here with the number of items for the user. It's actually expecting 1, but we got 0. So something happened with the users listing. So something went wrong with the sale. So let's go and figure out what actually happened with the. This is the advantage of using TDD, because you can figure out what the problems before you even write everything. So well, let's go back and look at the create item sale function and make sure that it's actually making that sale. So this is fine. So it is taking the listed and transfer it to the message value. So we are actually transferring that, then transferring to the whoever is buying it. We are changing the on buy, which is right. Sold is fine. Item sold plus increment is also fine. Then let's go to the fetch my items. Okay, one thing we missed is initially when we deploy the smart contract. So we initiated the item ID as 1, item ID as 0. Initially, when you start a counter, it starts with 0. But when we list it, what we did is we incremented that 1 before adding it to the our map. So that's what happened. So for that, because there is no 0 index, where we are fetching it, fetch all items, we instead of doing this, so we're going to increase this to +1 and make sure that we are reading it from the right index. So that should solve that problem. And then same thing for fetch my item function as well. So it's just a correction. It's good if we have the TDD, so that we this kind of problems we can find out early in the development stage. Let's go back and run our test again and see what happens. So now it seems like it's all working, and this pretty much covers covers for all the scenarios for our marketplace. So we have the Explorer collection, we have the My collection and function for that. And then now that we have the contract is completely ready and the UI ready, so let's start working on connecting that contract UI to the our local blockchain. Before we do that, we need to install a Metamask wallet on our browser. Let's go and search for Metamask wallet. So you can just install the Metamask wallet. So let's install it. Once you have that installed, you can open the Metamask wallet and create an account. This by default will create an on Ethereum mainnet. Create. And just to remember that you should not share the secret recovery phase or neither the private key anywhere in the external public internet. Otherwise, you will lose your account. It's really important. put that here. Okay, and that's done. So we created the now see if you can see that we created the MetaMask wallet account. So you can see that this is connected to the Ethereum mainnet, and you can go ahead and enable all the test network. So if you go and enable the test network, you would be able to see it's all connected to the local host and even other networks. So we need to start a local Hardhat network. What happens is if you start that, so I already started one here. So if you start this Hardhat network, it will spin off a local blockchain network, an Ethereum blockchain network, and give you a list of accounts, like somewhere around 20 accounts, and then you can will then the private keys for that account as well. So you can just simply use that to import it into the MetaMask. Let's do that. Go to Chrome and let's import an account. But an account using private key. So now we have somewhere around 10,000 into that account. That's one thing. And so far we were testing our contract code using Hardhat config, and we are testing it using the test itself, right? So we were never deployed that to any local network. To deploy the local network, we need to have something called a script. So when we initiate this Hardhat, it created a sample script for us. Let's work on to use the same sample script to deploy our both marketplace contract and the NFT contract. Let's rename this file to deploy. And first thing is we need to get the marketplace. To deploy that, then we need to make sure that this is getting deployed. So then we can just say that marketplace address. Next thing we need to do is get the NFT. So we have the NFT, so which we call the NFT marketplace. So let's deploy that as well. Deploy the NFT, we need to pass the marketplace address, and then say wait for that to deploy, and we'll add a console.log because we need this address to connect from our application, from our front-end application to the local blockchain network. Now that we have our Hardhat deploy script and the configuration, and we started a Hardhat node on our local machine, so what we can do is we can deploy this contract to the Hardhat local network by running this command, and it will give you our marketplace address and the NFT NFT address. So we're going to use that in our Next.js app. If we look at the our terminal where the Hardhat node is running, you would be able to see some transaction IDs. So see it tells you how many transactions it used and what was the gas used, gas fee, and things like that. So just some information on what happening on the local network. Let's take this and configure in our Next.js config file. So we already created something in the Next.js config for marketplace address and the NFT address. Let's put that there. So let's go back to our index.js, which is, if you remember, this is our index.js to explore the collection. So we need to make that call to pull all the information from the local blockchain network. Let me delete whatever is already there. There's a default value, so I'm just gonna remove all those things. Let me just change this value, and I'm gonna use something called use effect. Use effect hook of React to make the network call. Here I'm gonna write a function called load my collections, load all collections, or load collections. That's gonna be a function, so I'm just gonna write an async function for this. And another thing you need to understand is that when we run our npx hardhat, it created few files in an artifact directory. So if we look at that, so this is something called API. So we have something called marketplace.json. APIs is for interfacing with an service, right? So application programming interface. When you are interacting with a smart contract, this is called API, application binary interface. So I'll show you that moment in a moment, that how we import that into the client side and passing that into an Ether library to interact with our smart contract. There are a list of functions we need. So this is actually, it's like a spec, right? So if we can remember the API spec, this is like a spec. So it tell me what function is it and what kind of output input parameters it's expecting. Let's import this APIs into our Next.js app. So let's go ahead, import. So that's the marketplace.json, right? So then we're gonna go to NFT. It's the same thing. So we have the NFT here. So other things we need to import here is the Ether library, and we need to import Axios. And let's go and start working on our contract to fetch or the load the collection. So first thing, we need a provider for it. So let's write a provider, because we are not going to use anything any client provider at the moment. So we're going to use just a JSON RPC provider, which is by default. You don't need to pass any account details or anything like that. The second thing is actually importing the contract. So we're going to use the marketplace contract. So we say that ethers.contract and the process.env, which is we already configured something in the Next.js for the address. So we need to pass the contract address and the contract API and the provider. And then we're gonna get the NFT contract, because we need to use this NFT contract to pull some information from the about the item from the NFT. Then now finally we're gonna call marketplace contract.fetch all items. That's the function. So we're gonna use that function. So at the moment this is all fine. So we are getting the items, a list of items are empty. The next thing we want to write is, if you remember, when we are listing something in an NFT item, so we put that item in the NFT and we set the URL, because we are not going to store the metadata into that NFT contract itself. That's going to go into IPFS, right? So we need to. So what is happening here? We are pulling all the information from the marketplace. Now we need to make an API call to the NFT to get the NFT URL. That's where the IPFS URL. Then we need to make an API call to the IPFS URL to pull that information. Let's write a function for that. So what happens here is that we have the listings and it maps through that, and it'll make a call to the NFT contract and call for the token URI, which is part of the ERC721. Pass the token ID, and we wait for the metadata to come back. And get the token URI. And with the token URI, you can make an API call to the Axios, which will be an IPFS URL. So we're going to get that URL. Once we have that price, then we're going to format the price and we're going to add some information into it. The token ID, we convert that to number, and the image, name, and the description. Then we set everything to the use effect hook, because we're going to set to the state, set plus and set the loading into false. Let's see what happens. So now we are not getting any data back. So it's actually saying that no Teslas are listed from the marketplace for sale. So it looks good, because we are not getting an error. Now let's go ahead and start working on, because we don't have anything in the marketplace at the moment. So before buying it, we need to list an item. So then let's go ahead and working on the sell Tesla part. So we're gonna import few things here. So first we will import the ethers, then we'll import the IPFS HTTP client. And we're going to get a hook from use router hook from Next.js, and there's a Web3 model. This is where the model will connect to your Metamask wallet. And once that is done, so we need to set up a client for the IPFS client using Infura. So like I mentioned, so if you want to interact with a decentralized platform, you need to have something, a decentralized client running on either on your local machine or somewhere like Infura or an AWS account. For time being, we are using IPFS, Infura IPFS. So we're just gonna set up the client with that. Next, we need to import the ABIs from the addresses contracts. So I have the ABIs here. I'll set up a file URL just so that we can show the uploaded image into the form, and we're gonna use the use route. So let's use the use router as well for the file uploading part. So what we did is we created once the file is uploaded, we are uploading that to the IPFS. If you remember, we set up a IPFS client pointing to Infora. So we are sending that file into the IPFS. Then we create an file URL. Once that is done, then we need to we call the use state hook to set that into the file URL. So next thing we need to do after this is write a function to submit the form. So when the form is submitted, we need few information. One is the name, price, and description. So we will make sure that we have the name, price, and description, and the file URL is already there in the system. So once we have that, we stringify this information and send it to again upload that information into the IPFS. We could even save this in all this into blockchain, but as I mentioned before, we will every data you are adding into the blockchain will cost you a transaction fee, not for reading, for writing that information. So it's better to save this kind of any kind of metadata information into a decentralized file system like IPFS, and then put that file URL into the ERC721 token. So once we did that, we need to write a function to list that item into the marketplace. So we write a function to list to the market. What we did here is we created a Web3 model, and we are connecting to that Web3 model. This is where our MetaMask wallet will be connected to the user account. So that will get connected, and we'll get a signer. And after that, we are calling the NFT contract and putting that token there using the URL. So we will for the token, we'll create the token and do the set URL there, and we will get few information from there. Once we have that information, we'll make a call to our marketplace contract to list that item into the marketplace. Let's save this. Let's go to the UI. So let's go to sell a Tesla. So let's put some information. Let's call it for 108, and we'll upload a file. So that file will got uploaded to the IPFS, and we are showing the file URL as an image. Let's click on connection. So what happens, since we integrate the Web3 model, it'll pop up with the MetaMask wallet connection request, and it'll ask you to select which account you want to select. So we will select the account we imported earlier, and it'll show some information about what connection data will be shared from MetaMask to the website we are connecting to. Then after that, once we connect it, it'll show you a first call we are doing is the create token call. So for that, it'll show you the estimated gas price, which is the transaction fee. Once you select that, it'll show you I'll show you another pop-up, which is for the next listing that into the marketplace. The first transaction is complete. Now we can list to the second marketplace. So one thing we need to notice here, we need to pay a selling listing fee to the marketplace owner. That's why it's actually 0.25. So if you remember, the contract we set up 0.25 as the listing price for listing anything into the marketplace. Let's pay that gas fee and see what happens. So now that we have completed the item, so we created an item, NFT token, we listed that into the marketplace, and it redirected back to the Explorer collection. So if you see that, the Explorer collection is now currently coming with a Tesla model with NFT item we just created to the marketplace, and it's showing that. So kind of success at the moment. The next functionality we need for our UI is an option to buy the NFT. Let's start writing that. If you go to our index.js, so that's where we are actually listing all the collection. So there is a function we already wrote for called Vices Tesla. So that comes in when you click on that button. So it'll give you some information about the NFT. Let's start write the code to trigger an MetaMask model and pay the price for that NFT and do that transaction. In order to do that, the first thing we need to import is bring in is a Web3 model. So we will get the Web3 model. Then we'll ask something for the connection. We'll it's exactly the same thing we did for on the sell your Tesla page. So we will connect to the Web3 model. Then we'll provide that connection to the provider. We'll get the signer. Next, we will call the marketplace contract, passing the marketplace API. Then we'll set the price, because that price is coming from the NFT, which is this. Then we need to process the transaction. So we, if you remember, we had in the marketplace contract, we had a function called create marketplace sale. Right. So for that, we need to pass the NFT address. We need to pass the NFT.token ID, and then the value of the NFT. Then we need to wait for transaction to complete. And once that is completed, we need to make sure that the NFT is marked as sold. So it should not come in the explore collection page. So we need to make the call to reload the function again. Let's save this. Yeah, we need to import few things here, because if you remember, if you go back to the previous one, we had imported the Web3 model. So we need to do that. I think that's pretty much we need. Let's run this and see what happens. Save this function. Let's go back to our UI. Refresh it once. Let's click on the buy it now. So it comes with the create market sale, and it's asking for us to pay the estimated cost for that item, 100 ETH. So let's do that transaction. So the transaction actually got completed. So what happened is that since we refreshed the screen, it's coming that there are no items left in the marketplace for selling, because we already sold the item. Let's add a couple more. Let's call it for 25. So now we have two items in the marketplace. We had 3, then we sold 1 item, and we added 2 more. So we have 2 left in the marketplace. So other function now, the only screen which is pending is the my collection page. Let's start writing that. If we go to the my Tesla page, where we are actually listing out all the Tesla's collections for a particular user. So let's clean up something we brought before. So that means there is nothing listed at the moment. So if we go back to the UI, it should show empty collection. And we need to now we need to make a use effect call. Load my collection. So it should be something similar to what we wrote already. So we need to import few things. We need to get the Web3 model. That's one thing. Then we need to have the ether. Also, we need to import the APIs from the marketplace and the NFT. After that, we need to, when we are coming to this thing, we need to get the Web3 model connection and the signers. Do that. So once we have the signer, we can go to the index.js, and there is the same function as load collections. Instead of the JSON PC provider, we are giving a provider using our Metamask wallet. So if we get this, copy this function here. We have to change here just to the signer, just like that. And we get the marketplace API, everything is here. We get the NFT, and we have the set Tesla thing here. Let's run this. Yeah, seems like we forgot to add the import Axios. So let's import Axios from Axios. If we go to my collection, so that's thing, and then we have something called my collections. It's like it's giving the same data. Let's see. Seems like it's giving the same thing. Let's go back and see what happened. So yeah, so the problem here, we are actually calling fetch all items. Instead of that, we need to call fetch my items. Remember, we wrote a function to pull the NFT for a particular user. So we need to pass that fetch my items. Let's see. So yeah, so if we go back to the my collection again, now we have the NFT we bought for that particular user. Since it's already connected to the MetaMask, it will never ask you for the read information. It will never pop up for that MetaMask wallet. To see that it's working, let's go to the MetaMask and import another user from our local Hardhat network. Let's import a user number 15 and go to the MetaMask and import another user. What we need to do is we need to switch to the account we just created. Connect this. Now if you refresh the screen, you don't have, since that user haven't purchased anything, it will never show in this collection. So if you go back to the Explorer collection, that user, we can see the existing items in the marketplace. And if you change the user to the previous one and refresh the screen, it will show you the item for that particular user. There you go. We managed to connect all our screens into our blockchain contracts. To recap what we did today, we created an NFT marketplace using Next.js for the building the UI and for Solidity for creating the blockchain contracts. We created 2 contracts, one for the marketplace and one for the NFT token using ERC-721. We connected from our UI application to the blockchain network using MetaMask wallet. We imported a couple of users from our local blockchain network created using Hardhat to our MetaMask wallet and verified that it's all working fine. Hope you took back something from the session. If you have any queries, please reach out to me or join our blockchain Yama community. Thanks for staying with me through the session. Hope you will enjoy the rest of the event. Thank you.